So we're still working with exponential functions, and we are in Florida, which would be wonderful. And so you've got this function here where it's modeling the population of this Northport, Florida. Okay. So the initial population, what was the population in year 2010? So it's years after 2010 is this little function here. So this is that initial value I was talking about that would have come into play in the previous question. So the initial value is that number out in front of the parentheses, because remember it was c times b to the x power. That initial is that c value right there. Okay. Now, does this model represent growth or decay? If you have a b value greater than 1, that means you are growing. Okay, so my b value is a little bit bigger than 1, but even though it's bigger, we would still say that that is growing. Okay, so that's because 1.023 is greater than 1. Okay, that's why we are growing. Now, by what percent does this population change each year? So you are seeing how much are you above or below 1. So we are 0.023 above 1, and that is going to give me my percentage. Okay, so 0.023 as a percent would be 2.3%. So if it was a decay, you'd be subtracting from 1 to see the decay. Lastly, it's asking you to use the model to predict the population in 2027. A lot of people want to put 2027 into the exponent, okay? But it's not the population since year 0, okay? It's the population since 2010, which is our year 0 in this scenario. So this is 17 years after 2010. So I plug in that 17 in for the t right there. Using PEMDAS, I want to deal with the exponent first before I try to multiply those together. So I took it to the 17th power in my calculator, and I got 1.4719, and I multiplied those together to get 84,494 people. Okay. The situation below is a little bit different, but it's kind of the same concept here. This factory left the small town, unfortunately, and it has this function to represent that situation. Now, it's probably going to be obvious that it's a decay here because it's saying the factory left and the people left, so the population is going to get smaller. And so, again, we want to look at that initial condition of 98,000. That's my C value, that's C times B. Okay, that 9,800 is that initial value, and so that's 9,800 people when that factory closed. Now, the reason why this is decay is because 5/7 as a decimal is 0.714, and that is less than 1, making it a decay situation. Okay. So on this next question, a lot of people want to say that how much is being lost each year. A lot of people just want to jump to 71%, right? But it's how far away is 0.71 from 1. Okay, so again, the question you want to ask yourself is how far from 1 is the base of your exponent? How far from 1 is 0.714? Okay, so that's why in red over here, I took away 0.714 away from 1 to get 0.286. So since it's 0.286 away from 1, that's how much I was lost. It might be a little bit confusing to leave the 71.4%, so I'm going to delete that out of there. Part D is saying, what is the population after 10 years? So that's when you're going to plug in 10 for that exponent up there. So it's 5/7 to the 10th power. Again, I don't want to multiply those first. I want to take 5/7 raised to the 10th power. We mean this decimal there. I'm going to multiply by 9,800 to get 339.